Right, this video is on systems of linear equations and inequalities. So we've done linear equations and inequalities. Systems just mean that you have more than one of them at a time. So we're going to say a system is two or more equations or inequalities. And you could have an equation and another equation, or two inequalities, or you could have a mixture of the two. And it could be two, it could be three, it could be four. Typically, we stick to four or less. Today, most of them are just two. So first, we have a system of equations. And so we're going to go ahead and graph this. So if you guys recall the cover-up method, anytime you have an equation in standard form, you can use that method. And so first we would look for the x-intercept by covering up the y. So that gives us that the x-intercept equals 2. And then we can do the cover-up method of the x to find the y-intercept. And so the y-intercept also happens to be 2. And then from there, we can go ahead and just graph it. With the other one, the cover-up method doesn't work as well because we're going to have a fraction there. So I'll go ahead and solve for y. So I'm going to minus the 2x over to the other side. So that gives me negative 3y equals negative 2x plus 9. And then to get the y by itself, I'm just going to divide by negative 3, divide by negative 3, divide by negative 3. So y equals negative divided by negative is positive 2/3 x. Positive 9 divided by negative 3 is negative 3. So for this one, I have a y-intercept of negative 3. And then my slope there is to go up to right 3. So up to right 3, up to right 3. And then I can go backwards as well. And I'll go ahead and connect those points. So once you have graphed a system of equations, in this case, then the solution for that system is where the two graphs cross, okay? So I'm going to write a note to myself. The solution is where the two graphs cross. And we write that like a point xy. All right, so the solution for this system of equations is right 3 down 1, so that's 3 for x, negative 1 for y. So x equals 3, y equals negative 1. All right, number 2. So for this one, we could use the cover-up method, but x equals negative 9, that's going to be off the graph a little bit, so I'll go ahead and just solve for y. So first, I'm going to minus the x over to the other side. So I've got negative 3y equals negative x minus 9. And then I'll go ahead and divide by negative 3 to get the y all by itself. So this x really does have a 1 in the front with it. A negative divided by a negative makes a positive, and then 1 over 3. And negative 9 divided by negative 3 is positive 3. So we are going to have a y-intercept of positive 3, and then the slope is that it goes up 1, right 3. All right, and then our second line says it has a y-intercept of 4 and a slope of 1/3, so it also goes up 1, right 3. And what happens here when you graph these is you actually get two parallel lines, and we know that since they're two parallel lines, they are never going to cross. And if the solution is the intersection of the two lines, and these two lines are never going to intersect, then our answer here is that we have no solution. So no solution, we could say the lines never cross. All right, I'm going to leave 3 and 4 to do in class because we're going to use a calculator on those. But we can go ahead and flip to the back page. So here we're going to do systems of inequalities. So a system of inequalities is just meaning you have 2 or more inequalities. And we could have a system, like I said, that's kind of mixed. But we're going to write this on our notes, not because you've never seen it, but just as a reminder. Less than and greater than, and whenever you have those, that means that our line is going to be dotted. If you have a less than or equal to or a greater than or equal to, that means we're going to have a solid line. So that's a good reminder to start with. So we're going to go ahead and graph these, and then I'll remind you of some more things as we're doing them. So here we have a y-intercept of -2, and then from there we go down 1, right 3. So down 1, right 3, down 1, right 3. We can go to the left as well. Because of the inequality symbol, I know that I'm going to have a solid line. So I can go ahead and graph that. And then after this, I go ahead and I pick a point to plug in, and that helps me figure out my shaded region. So I'm going to write that little reminder up here at the top. So plug in a point to shade. And the point that we typically use is 0, 0. But if 0, 0 is on the line, then you have to use something else. So if I look at this one, 0, 0 is not on the line, it's above the line. So that means I'm going to plug 0 in for x and 0 in for y. So I'll have y is greater than or equal to -1/3. Sorry, you couldn't even see that. Y is greater than or equal to -1/3 times x minus 2. So 0 is greater than or equal to 0 minus 2, which means that 0 is greater than or equal to a -2, and that is true. 0 is bigger than a negative number. So since 0, 0 is above the line, and that's true, that means that for this one we're going to shade up here. And then we'll go ahead and I would switch colors if you have a pen or a colored pencil or a marker or something. And so for this one, we're going to draw this other line. This one has a y-intercept of 3, and the slope is -2. I'll go ahead and write that as a fraction. So I've got -2/1. So I'm going to go down 2, right 1. Down 2, right 1. Down 2, right 1. And based on the symbol for this one, I should do a dotted line. All right, so same thing, I'm going to plug in 0, 0 for this one as well. So 0 for x, 0 for y. So that gives me y is less than -2 times 0 plus 3. So 0 is less than 0 plus 3. 0 is less than 3. That is true. And so the point 0, 0, if I'm ignoring all the pencil that I did and I'm just looking at the red, 0 is on the left side of the red line. So that means that it was true, so I should shade to the left side of the red line. So now when we try to determine what our solution to the system of inequalities is, we're going to look at the double shaded area. So we have our shaded area for the original equation, and then our second equation, and the double shaded area is right in here. And so that is our solution. So I'm going to go in and I'm going to make this extra dark. This is our solution. All right, and so I'm going to write that up here in my notes. I'm going to say the solution is the double shaded region. So if someone wanted to know a solution that would work for the system, then you would pick like this point right here. You could say -3, 3, or you could say -2, 4, or -6, 1. All of those points would work, anything in that dark region right there. Okay, and then last problem. So here, again, the cover-up method, not going to be the best for me. And so I'm going to go ahead and solve for y. So I will minus 2x over to the other side. So I get y is greater than or equal to -2x minus 3. So I have a y-intercept of -3. And then from there, I'm going to go down 2 over 1, down 2 over 1. And the inequality symbol tells me that should be a solid line. And I'll plug in 0, 0 to see what side I should shade on. So I have 2 times 0 plus 0. 2 times x plus y is greater than or equal to -3. 0 is greater than or equal to a negative. That's a true statement. And so I'm going to shade on the side with 0. Okay. For the other equation, it feels like the cover-up method would work pretty well. -x equals 0, so that's an x-intercept of 0. But then if I cover up the x, I can see that the y-intercept is also 0, and that's just 1 point. That's not enough to draw a line. So that means I'm going to go ahead and solve for y on this one as well. So I'm just going to add the x to the other side. So that gives me the inequality y is less than x. And if I want to put some more numbers in here so it's easier for me to graph, then I know that the number in front of x would have been a 1, and I can write that as a fraction. And that since there's no number on the end, that number really would have been 0. So I'm going to start at 0, and then I go up 1, right 1, up 1, right 1. And then I can go the opposite direction. And because of the symbol on this one, we're going to have a dotted line. So this time we can't use the point 0, 0 because it's actually on the line, so it wouldn't help us shade on one of the sides. So you can pick any point you want. It just has to be on a certain side of the line. So I'm going to go ahead and pick the point 1, 2. 1 for x and 2 for y, because that's going to be pretty easy to plug in. So if I use the point 1, 2, then I can plug 1 in for x. So I'm going to have negative times 1 plus 2 for y. So I've got -1 plus 2 is less than 0. 1 is less than 0, and that is false. So this point right here, it's above the line, that's a false statement, so that means that I need to shade on the other side of the line, which is over here. It was false. And now I can go ahead and do my double shade. So there's my solution to the system of inequalities.